All right, notes for 3.5. We're going to start with your packet, and then we'll move to your notebook. We need to go back to this page in your packet again. We're going to finish this one off today. This is section 5 here. With section 5, we're really not doing anything new. We're just taking stuff we've already done and doing it kind of backwards. And when we take an if-then statement and we kind of flip it around and do it backwards, we call that the converse. Converse is where you flip around the if and then parts of an if-then statement. So what we're going to do is just take the theorems we've already had and flip them around. Corresponding angles postulate said if the lines were parallel, then your corresponding angles will be congruent. If we flip that around, we would just say that if your corresponding angles are congruent, then we'll know the lines are parallel. So that's the converse of the corresponding angles postulate. So now that's going to work both ways. If you know the lines are parallel, then we know our corresponding angles are congruent. But it also goes the other direction. If we know the corresponding angles are congruent, then that's enough to tell us the lines are parallel. And then we'll just work our way right down the line. It's going to be the exact same thing with each of these. We're just going to flip the if-then statement around. Alternate interior angles said if the lines were parallel, then your alternate interior angles are congruent. Converse of that's going to flip it around and say if your alternate interior angles are congruent, then the lines are parallel. Consecutive interior angles are next. And this is, remember, the one that's different. Consecutive interior angles theorem said if the lines were parallel, then your consecutive interior angles are supplementary. Converse of that, we'll flip it around and say if the consecutive interior angles are supplementary, then the lines are parallel. And our final one, the alternate exterior angles theorem, said if the lines are parallel, then the alternate exterior angles are congruent. Flipping that around, the converse would say if your alternate exterior angles are congruent. Oops, I've got angles in here. If your alternate exterior angles are congruent, then your lines are parallel. And those are the things we're going to use as we go through the problems that you're going to see in section 5. And the homework comes out of page 210 out of the book. And this is the way you'll see it when you get to that. Okay, so that's the part we need to fill out. Now just kind of take that, just kind of set it aside because we're going to use that as we go through some of these problems. The rest of the notes we're going to do in your notebook. And like always, I'll get the date in there. Today is Wednesday, October 21st. Section 3.5. And the notes are not terribly long. We've just got some examples we're going to go through, and then we're going to do some proofs. There's 3 short proofs we're going to do today. first we're going to start with some examples. So let's start with a picture. They're going to give us a picture of 4 lines that are going to intersect. And we're going to call those 4 lines A, B, C, and D. And then typically they'll number the angle marks or the angle positions here differently each time. So we've got angles 1, 2, 3, and 4 here. 5, 6, 7, and 8 here. 9, 10, 11, and 12 are on the left side, and 13, 14, 15, and 16 over here. And then our directions for this are going to say something along the lines of determine which lines are parallel. I'll use the symbol for parallel. And they're going to also, kind of like what we did yesterday, make us justify our answer with a postulate or theorem. And that's where that packet, the thing we filled out in the packet, that's where that's going to be helpful. And then what we're going to do today is just kind of the reverse of what you did back in section 2. Back in section 2, they told you the lines were parallel, and then you had to pick out which angles were congruent or supplementary, that type of thing. Now we're going to do it the other way around. So for an example here, let's take angles 2. Let's say angle 2 is congruent to angle 8. And from that, they're going to have us figure out which lines are parallel, and then we're going to justify it with a theorem or a postulate. So obviously, the first thing we got to do here with 2 and 8, we got to figure out where they're at in the picture. You go over to your picture, here's angle 2, here's angle 8. So they're sitting up here on the top part of our picture. So again, like we did last time, what I'm going to do is cover up the bottom part of our picture, because angles 2 and 8 are not on the bottom part. And when you cover that up, it kind of looks a little bit more similar to what you're used to seeing. You've got one transversal, 2 lines being intersected. Now, they're telling us that 2 and 8 are congruent to each other. And first of all, what kind of angles are 2 and 8? What's the name of those? They're opposite sides of the transversal, inside the lines being intersected. What do we call those? Alex?
Alternate interior.
Alternate interior. And we just had the theorem that said if the alternate interior angles are congruent, then the lines are parallel. So as we look at our picture here, 2 and 8 are alternate interiors. They alternate interior angles. They are congruent to each other. That's going to make the lines parallel. When you look at your picture, the 2 lines that would be parallel would be A and B. So that's our first answer. A is going to be parallel to B. They don't ask us to do this, but C would be the transversal. C is the line that goes through both of them. And then we have to justify with postulate or theorem, just like you did the other day. Postulate or theorem is usually going to match up to the type of angles we're working with. We said 2 and 8 were alternate interior angles. So this is actually the converse of the alternate interior angles theorem. If you happen to just say alternate interior angles theorem, I would understand what you're talking about, and I would count that as okay. The main thing is that you understand which type of angles we're working with. So if you just said alternate interior angles theorem, I would be okay with that. All right, let's try another one together. On this one, they're going to say that angle, the measure of angle 8 plus the measure of angle 13 equals 180. And you might be able to look ahead a little bit here and see if they're adding up to 180, you know what that means. They're supplementary to each other. So we're probably talking about consecutive interior angles here. So let's make sure we are. We got to find angles 8 and 13. 8 is right here, 13 is right here. Those two are on the right-hand side of the picture, so I'm going to cover up the left-hand part because we don't need that. So here's our two lines, our transversal. 8 and 13 are consecutive interior angles. And we know if consecutive interior angles add up to 180, then our lines are parallel. That's the consecutive interior angles theorem, or the converse of it. If your consecutive interior angles are supplementary, then the lines are parallel. So we do have consecutive interior angles that are supplementary. They add up to 180. Because of that, our lines are parallel. C would be parallel to D. And then for our reason, our justifying part, we said they were consecutive interior angles. So this is the converse of the consecutive interior angles there. And once again, if you messed up and just called it the consecutive interior angles theorem, I would be okay with that because I know what you're talking about here. All right, I'm going to give you one of these to do all by yourself here. We'll call this number 1. Let's take angles 3. Angle 3 is going to be congruent to angle 11. So see if you can take it from there, figure out which two lines are parallel, and then justify it with a theorem or postulate. More time with this one. Okay, angles 3 and 11 are going to be congruent to each other. They're over here on the left-hand side of the picture. So what I'm going to do is cover up the right-hand part. And a lot of you weren't covering up the right-hand part. When you don't do that, it makes it harder to see what's going on. So if it helps you, cover up the right-hand part. 3 and 11 are going to be sitting on these two lines with this transversal. 3 and 11 are corresponding angles. So if they're congruent, that means these two lines are parallel. If I come over here to the right, those two lines are C and D. So C is going to be parallel to D is one answer. And then we said they were corresponding angles. If you go back to your little chart here, corresponding angles is up at the top. Converse says if the corresponding angles are congruent, then the lines are parallel. This one, our answer is converse of the corresponding angles postulate. And once again, if you just call it corresponding angles postulate, I would know what you're talking about. That'd be okay. All right, any questions with those right there? Anybody need to see more of these? Okay, so let's go to some simpler stuff. On this one, the picture is going to have just two lines intersected by a transversal. Let's see here. We'll call this letter C. There's our picture. We're going to call these lines A, B, and C. And on this one, they're going to give us just two angles. This angle here is going to be 5x plus 7. And this angle down here is 7x minus 21. And your directions will tell you something along the lines of find x so that A is parallel to B. So in other words, in this picture here, they want A to be parallel to B. We need to find x. We need to find the one number that's going to fit in for x that would make A parallel to B. And to do this, it just goes back to that theorem sheet we filled out a little bit ago. Look at the two angles we're given, 5x plus 7, 7x minus 21. Those are alternate interior angles. And we know in order for the lines to be parallel, alternate interior angles have to be congruent to each other. So if I want to find x so that these lines are parallel, I need these two to be congruent to each other. So to find x, I'm just going to make an equation where I put these two equal to each other. 5x plus 7 would equal 7x minus 21. And then we'll solve it from there. I'm going to subtract 5x from both sides. So if I subtract the 5x, I'm left with 7 on the left. 7x minus 5x is 2x. We'll add our 21 to both sides. We get 28 over here. 28 divided by 2 is 14. So in order for these lines to be parallel, x would have to be 14. The reason x needs to be 14 is that would make these two angles congruent to each other. And it might be helpful to just go ahead and show that here. Put 14 in here. 5 times 14 is, let's do it on the side here, 70. 70 plus 7 is 77. If I come down here and do it, 14 times 7 is 98. 98 minus 21 is 77. So the only way those two would both end up being the same is if x is 14. Questions with that? All right, let's try one more of these. We'll make our picture a little bit different here. This time A and B are the two horizontal lines, and angle C is this diagonal one, or line C is the diagonal one. And we're going to do the exact same thing. We're going to find x so that A is parallel to B. This time they're going to give us two angles here. I'm just making this up, so hopefully it works out well. That one's going to be x plus 50. This one's going to be x minus 10. And we need to find x so that A is going to be parallel to B. Now here's A, here's B. In order for these two lines to be parallel, look at the kind of angles they're giving us. The x plus 50 and the x minus 10, those two are consecutive interior angles. If you go back to your theorem, in order for the lines to be parallel, what has to happen with consecutive interior angles? Yep. They have to add up to 180. So that's what we're going to do with these two angles. We're going to add them up and set them equal to 180. So our equation would be x plus 50 plus x minus 10 equals 180. On this equation, we've got to do some combining some like terms first. X and x give you 2x. 50 minus 10 is 40. And I'm going to subtract the 140 from both sides, or subtract 40 from both sides. That gives us 140. And 140 divided by 2 is 70. So x is going to be 70. Now I'm going to check that out just to make sure it works. If I put 70 in up here, 70 plus 50 is 120. If I put 70 in here, 70 minus 10 is 60. Do 120 and 60 add up to 180? Yep, so I found the one number that can go in for x that would make those two add up to 180. So that makes lines A and B parallel. All right, does anybody need to see another example like that? Okay, those are a little more straightforward. The last thing I have is some proofs. Now, eventually, we're going to get to the point where we have you fill out proofs all by yourself. It's not going to happen yet. It's not going to happen until chapter 4. So we're going to start to ease you into this. So today we're going to do a few proofs just to show you how these work. And we're going to do the proofs of the theorems we just talked about. And these are all pretty short to do. We'll call this proof 1. We're going to have a picture here. These are lines A and B. We have a transversal going through them. And on our picture, we're going to have 3 angles. We have 1, 2, and 3. And just like all proofs, we're going to have a given. The given here is going to be angle 1 is congruent to angle 3. They're also going to give us a proof statement. We want to prove that A is parallel to B. And just to give you a little bit of an idea of which theorem we're proving here, angle 1 is congruent to angle 3. Those two are corresponding angles. So we're saying if the corresponding angles are congruent, then the lines are parallel. That's your corresponding angles postulate. And you don't need too many lines. This is a pretty short proof here. It's only going to take us 4 lines to get through this. We're going to put our statements on the left, our reasons on the right. And hopefully you find as we do these proofs, you're going to see these patterns start to develop. Just like we did with our angle proofs and our algebra proofs, there's a lot of patterns that will kind of form. Same thing's going to happen with these proofs. And now we're going to put this together all by ourselves. So we'll start with the first step. Even if you have no idea what to do with this proof, you should be able to get step number 1. What's the first step always going to be? Always going to be the given. Our given is angle 1 is congruent to angle 3. That's given to us. And if you want to, you can mark that in your picture. That might help you out later. 1 and 3 are congruent to each other, so I'm going to mark them as congruent. And then for step 2, I'm going to go to something that will kind of, one of the patterns I talked about that will happen a lot of times in these proofs. If you just look at the picture, hopefully one thing that jumps out at you is angles 2 and 3. Those two are right across from each other. What do we call those angles when they're right across from each other? Vertical angles, yes. And we always know vertical angles are congruent. So when you see your picture like this and you've got vertical angles in there, we will almost always use that in the proof. So I'm going to go ahead and go right to that. 2 and 3 are vertical angles. We know automatically vertical angles are congruent. So my second step here is going to be that angle 2 is congruent to angle 3 by the vertical angle theorem. And usually what will follow that up, as soon as we put vertical angles theorem in there, usually it's going to be followed by substitution. If you look at your 2 previous steps, we have 2 things that are congruent to angle 3. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 3. So what that allows me to do is I can substitute it in. I can put angle 2 in for angle 3 up there. My new statement would be angle 1 is congruent to angle 2. That's coming from substitution. And now that's going to allow me to say what I want to say for my proof statement here. I'm going to go ahead and mark this here. Angle 1 is congruent to angle 2 now. And then I can go ahead and finish this off. Angle 1 and angle 2 are alternate interior angles. And we have our theorem sheet here. If our alternate interior angles are congruent, where is that one here? Right here. If the alternate interior angles are congruent, Then your lines are parallel. So this one right here, converse, alternate interior angles there. And you're going to find as you do these proofs, the more of them you see, the easier they get because they kind of follow the same type of pattern. I didn't fill in my statement here. It's, last statement needs to be A is parallel to B. That's what we want to prove. What you want to prove will always be that last statement. All right, there's our first one. Let's do another. Usually it's the second or third one we do that really kind of a lot of people starts to make sense for them. All right, on this one, our given, I'm going to abbreviate given with G, capital G. Our given is going to be M is parallel to N. I'm going to abbreviate our prove with a P. We're going to prove that angle 1 is congruent to angle 2. Pretty similar picture. This time we're going to have M and N. Transversal coming through. And again, we'll have 3 angles on here. This time our angles are 1, 2, 3 in those spots. And we're going to come up with the proof. I'm going to put capital S for statements, capital R for reasons. And as we go through this, I think you'll start to see these things showing up again, these patterns showing up. So I think it'll be even easier the second time through. Anybody need more time to copy it now? All right, who thinks I can give us our first step? Yep, Al, or Pardon. The given, yep. M is parallel to N. That is given to us. And then I'm going to go ahead and put that in our picture. M is parallel to N, so we got this one parallel to this one. And that's going to open up all those theorems we talked about in section 2. If the lines are parallel, then we know all kinds of things about their different angle pairs. All right, step 2. This might be a bit of a stretch at this point, but we'll give you a shot. Anybody think they can figure out step 2? Look at the picture. That might give you a hint. Yep.
What would be the 1 and 2 are like congruent or something?
Not 1 and 2 yet. You're close. What'd you say?
1 and 3.
Not 1 and 3.
3 and 2 are vertical.
3 and 2 are vertical angles. So just like we had in the first one, you got vertical angles across from each other. Same thing's happening here in proof number 2. You've got vertical angles across from each other. And we always know vertical angles are congruent to each other. So we can say that angle 2 is congruent to angle 3 by the vertical angles there. And again, if you want to mark those in your picture, you can. Those 2 are congruent. And now our third step, I'm going to go back to the given. They said M is parallel to N. So we've got parallel lines here. And now, as soon as those lines are parallel, angles 1 and 2, which are corresponding angles, are going to become congruent. Because once the lines are parallel, corresponding angles are congruent. So now I can also say that angle 1 is congruent to angle 2 by our corresponding angles postulate. And you'll notice steps 2 and 3, if we did those in a different order, if we did step 3 first, that would be fine. You just have to have them both in there. Now I'm going to put this in there. Angle 1 is congruent to angle 2, so we'll mark that congruent. And that's what we wanted to prove. So step 4 here, we can say that angle 1 is congruent to angle 2. Wait a minute, I did something wrong here. That's actually a way to do it. I did it with one less step. Let's take that out of there. 2 is congruent to 3, 1 is congruent to 2. Yes, I think that should do it. All right, there's our second proof. Now, at this point, hopefully you're just kind of getting the hang of these a little bit. Obviously, we don't expect you to fill out a proof all by yourself yet, but we're going to get to that point when we get to chapter 4. How many think they're kind of getting the hang of these proofs a little bit better? Okay. Now, the last proof we're going to do is going to be like what it's going to be on your test. Because on your test, we're still going to have you here filling in chapter 3, we're going to be filling in the blank. So we're going to do one as a fill in the blank. So that's how you'll see it on the actual test. This will be proof number 3. Given this time as B is parallel to W, we're going to prove that angle 1 is congruent to angle 3. There's B and W, our 2 lines. Here's our transversal. And again, they're going to give us 3 angles. But this time, we are going to give you fill in the blank. Statements on the left, reasons on the right. We're going to do this one in 4 steps. We're going to give you the 4 statements, and we're going to fill in the reasons. This is the way it's going to look on your chapter 3 test when we get to the chapter 3 test next time you come to class. Anybody need more time to copy it down? All right, let's try it out. These go a little quicker because all we got to do is fill in the reasons here. First step says B is parallel to W. Where's that coming from? That's given. Matches up to the given. First step is given. And if you want to, you can put that on your picture. B is parallel to W. And those 2 lines are parallel. Step number 2 says angle 1 is congruent to angle 2. Can anybody figure out where that comes from?
Vertical.
Yep. Vertical what?
Vertical angle. Steering?
Steering, yeah, vertical angle steering. Angles 1 and 2 in your picture are vertical angles. As soon as you see that, you know that they're congruent to each other by the vertical angle steering. So there's step 2. And again, if you want to mark those as congruent in the picture, you can. Step number 3 says angle 2 is congruent to angle 3. Here's where that's coming from. We said in your first step the lines are parallel. And then we got angles 2 and 3 here are corresponding angles. And we know as soon as the lines are parallel, corresponding angles are congruent by the corresponding angles postulate. And if you need to see that, here's that little theorem sheet. Corresponding angles postulate says if the lines are parallel, then the corresponding angles are congruent. That's where step 3 comes from. And then in step 4, if you look at your previous 2 steps, you have 2 things congruent to angle 2. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 2. So what we can do is we can take angle 3 and put it in for angle 2. If I do that, angle 1 stays on the left, angle 2 on the right becomes angle 3. What property is letting us take one thing out, put another in for it? Substitution. So at this point, probably still a little bit easier to just fill in the blank. But eventually, we're going to get to the point where you put these proofs together all by yourself. All right, any questions with that last one? Okay, like I said, this is how it's going to look when you get to your test. Okay, that will cover your notes for section 5. The homework is on page 210. And on your front of your packet, it tells you what numbers those are. Let's see. Last time, okay, page 210, we're gonna do number 6, and then 8 through 21. Answers for those are on Google Classroom, like always. So you can check them as you go. If you finish that today and you want to turn it in, you can. We'll put it in the grade book today.